All right, so complex numbers. We talked about a radical cannot be in the bottom of a fraction, yes? What's another rule with a radical? Think. Okay, but what else? Besides not being in a denominator, what's another rule that can't happen with a radical? It can't be negative, right? What if I told you now it's going to be negative? Here's what we do. We're going to let the square root of -1 be represented with an I. For, what do you think the I stands for? Imaginary. Okay. We're going to treat it like any other variable, but every time you see it, it's going to hold the place of the square root of -1. Now let me ask you this. We've talked a lot about opposite operations. And the opposite operation of a square root is a what? A square. So what do you think you would get if you squared I?
An imaginary number.
Oh.
Close.
Oh, negative.
-1. Because if you think about it, here's what happens if you've got the square root of 3 squared, what's it give you? 3. If you've got the square root of 10 squared, what's it give you? 10. It's whatever it is, it cancels it out. So I squared is going to be -1. So I want you to keep that in mind as you go. If my pen will work, I can put this up here. No. Now, if you raise I to the 4th power, in other words, if you squared I squared, then you'd get +1. Because -1 times -1 is +1. Then we start getting into the iterations of I. But for right now, let me just stop with I squared is -1. Yes. On.
I'm a bit confused with how we went from, like, you squared, did a -1 squared twice. Wouldn't that be positive?
You're not, we're using opposite operations here to say that a square root and a power of 2 cancel each other out. So if they cancel each other out, if I square I squared, what I'm really squaring is the square root of -1, which leaves me with -1.
Just continue with it later. Take your same square too many times and it's like,
See, the thing is, my very smart calculator says that right there.
Because you're not set, if you hit mode, you have an imaginary or a complex mode and a real number mode, and you're set in real number mode. Imaginary numbers are not real numbers. They're imaginary numbers. It's a whole other number set, okay? It's another dimension, that's right. All right, so here's what we're going to do. When we encounter a negative number under a radical, let's say negative 21. We're going to say, well, I can't have a negative under the radical, so what I'm going to do is I'm going to, remember we can split up this way? So this is going to become I times the square root of 21, of course, with the plus or minus in front. I'm literally, yeah.
Instead of doing the little radical thing,
You could just put the I.
yeah, but why?
Because we can't have a negative under the square root.
Oh, so whatever the negative is.
Drop it off and put an I out front.
It's like -32.
Doesn't matter. Doesn't matter, yeah.
So -1 thing was an example. It's literally
That is the rule forever and ever. I is the square root of -1. Yep, always. Colin? Yes. How about this? 25 is a perfect square. And because I'm going to use good math manners, I'm going to let the I follow. Because if we have a coefficient, we usually let the variable follow it. But we took the I out, right? So it was I times the square root of 25, right? Square root of 25 is 5. I just flipped multiplication. Multiplication is commutative, so I can do it either way, and pretty math puts the coefficient before the variable. When it's a little bit different, when it's a radical, we put it in front. We're still going to simplify the exact same way.
Wait, I can't read your.
Which
Oh,
one?
that's an arrow. That's an arrow?
Yeah, that's an arrow, I'm sorry. So we're still going to simplify radicals the same way. Let's say I asked you to simplify this. What would you do first? Take the I out. And somebody else is saying figure out what? Perfect square goes into 8. What is it? 4 and 2? I got the I got the 4, I got the 2. Square root of 4 is, so I'm going to write this as 2I square root of 2. Yes. Yep. And make sure the plus or the minus is in front of the whole thing and not between. If I put it in between, then it's saying 2I plus the square root instead of 2I times the square root. Does that make sense? Does it make dollars?
I don't like this.
You don't like this? I'm sorry. So, okay, where are you confused? You don't know where you're confused.
Why does that? Like,
Girls, huh?
I'm not sure if that
Why does the I do what?
go in between the two.
Just how we would normally write, guys. I can't talk over you. It's hard, okay? And other people are trying to understand, so I need your attention up here. This is just in general. I mean, it's not wrong if you do I too. It's just in general. We always put the variable after the whole number. Think if it was an x, you wouldn't put x2. You'd put 2x, right? Okay. Everything, same thing that we did Friday. It's the exact same stuff. Only now when you see a negative, you pull out the negative and make it an I. So let me show you an example. Please remember this whole chapter is about solving quadratics, right? And this one we're solving with square roots. So let's say that I have 2x squared plus 11 equals negative 37. And I need to solve that. What do you do? Minus 11. Okay, well now I have 2x squared equals negative 48. Close. Divide by 2 first because I need to go opposite order of operations. So I'm going to divide by 2 first. So I've got x squared equals negative 24. Now I square root. Same steps, same everything. Now I've hit a point of something new. What's the new? Take the I out. Can you break down 24? 4 and 6. So I'm going to take the whole number, the perfect square, 2I square root of 6. Yeah. You said, can we try one on our own to see if we really understand it? And I said, sure. 2x squared plus 18 equals negative 72. Work through that one, then we'll hit it together. All right, so as we solve this, let me reel you back in, guys. I'm going to subtract 18. I get negative 90. Divide by 2, I get negative 45. Square root. 9 and 5. Nine and 5. So I get plus or minus 3I root 5.
That's the first time I got that, right?
The title of this lesson was not imaginary numbers, which is what it was complex numbers.
Complex.
Well, this is my rule.
So let me tell you what a complex number is, and then we're going to talk about some operations with complex numbers. A complex number is made up of two parts. Okay? It's got a real number part, and then either added or subtracted to it, it has an imaginary number part. So a complex number may look something like 2 plus 3i. Yes. 7 minus 5i. 1 minus I. I could go on, but the point is, it's a combination of a real number and an imaginary. If it doesn't have the real number part on it, it's just imaginary. Okay? But if it has the real number part to it, then it's a complex number. So what we're going to do is we're going to add, subtract, multiply, and divide complex numbers. Y'all ready? Scenario 1. Addition. That's a Roman numeral 1. Addition of complex numbers. If you remember that an imaginary number simply has a variable hooked to it, you treat it as such. So if I have 2 plus 3i plus, Cullen, give me a complex number. Any random complex number you can think of. Okay. If I want to add these two, you acted like that was a hard task, and it okay. You did. If I add these two, what do you think I might do? That's exactly right. This is adding. I'm adding complex numbers. So I just combine the terms that are the same. I combine the real number part.
So would it be 6 plus
It'd be 6 plus 9i. When we add like terms, we keep the exponent the same. If it was multiplied, it'd be squared. That's it. I told y'all, it's not, y'all are like freaking out on me, but it's okay. A portion of it. What? No. Okay. I'm going to assume I don't need to do another addition example. Let's subtract then. It's fun. Isis, give me a complex number.
7 plus 3i.
Justin, give me a complex number with a subtraction in the middle.
14 minus 6.
Why would he do it? Why would he do that?
I thought I was giving you a long decimal, but then I decided.
All right. So when we subtract, this is just like subtracting any two binomials we ever have. We have to remember that when we're subtracting everything in that parentheses that follows. So if you're a same change kind of person, I don't know if y'all do that. I'm not really a, okay. This is really like plus a -1 here in front. No. You do not have to. You do not have to. But here's what you have to remember is I'm doing 7 minus 14. And I'm doing 3 minus -6. If you were, okay, so if these were x's, what would you do? What I kind of did was I said, okay, I'm going to change this, this, and this. I distributed a -1 through is what I did.
Is that 7 plus 9? Does that say 3I minus
Yes. 6i.
That's the answer?
That would be the answer. This one's a little bit harder because of that minus in the middle, right, Evan? Give me a random complex number.
2 plus 2I.
Give me another.
4 plus 4I.
Subtract the terms that are common. 2 minus 4 is what? -2. 2i minus 4i is... Does that make sense? It's not. It's literally combining like terms. Because it's subtraction. So I have to do 2 minus 4 and 2i minus 4i.
But you just go in order of like.
Yeah.
So it's like, say the first set of numbers is greater than the second, so it would be a positive.
No, right. No, it'd be negative.
It would still be negative.
Let's multiply. Y'all don't overthink addition and subtraction. No, but it's a little more complicated. It's really not. Thank you, SpongeBob. 11 hours later. Sarah, give me a complex number.
7 plus 9. No.
We need one more, yeah.
Okay. 3 minus 2i.
Multiply. Looks like I have two binomials here. Do you agree? When you have two binomials to multiply, what do you do? And there's one little thing that's going to pop up that I'm going to show you whenever we start multiplying this, but it will not be hard for you. All right, let's multiply. 7 times 3.
21.
7 times -2i. 9i times 3. It is. 9i times -2i. Now, let's put those middle two terms together because we know to do that, right? -14 and +27 is what? Yeah. Squared, yeah. -21, what'd you say was -14i and 27i? Now, here's the kind of new thing. I've got -18i squared. Can't just randomly square root. But I do know what I squared is. Remember I told you what I squared was? -1. So watch what happens if I've got -18i squared. You get +18. The only thing, yes, and then you combine like terms. The only thing I squared does to a number, and listen carefully, is it changes the sign and drops off. Does that make sense? Why? So this is not -18i squared anymore. It is +18. Anywhere I see an I squared, it changes the sign of the number and goes away. So this is plus 18. So now Sarah said, oh, we got some real numbers here that we can combine, and that's absolutely correct. 21 and 18, 39 plus 13. Does that make sense?
So you want to flip it?
No. Whole number and then imaginary. That's standard form of a complex number. Okay. I'm not going to do another example of this because you're going to get plenty of practice with this with division.
Should be like
Yeah.
picture.
Huh?
What do you mean?
Huh? You shall see. Keep in mind as we work through this that I is the same thing as what? No, that's I squared. The square root of -1. I is a radical and must be treated as such, okay? All right, so let's do division. Now, before I show you division with complex numbers, let me just go back and show you if we happen to be dividing by an imaginary number. Let's say 5 over 2i. When you have a radical in the bottom, what do you do to get rid of it? Multiply the top and the bottom by that radical, right? What's the radical in the bottom here? Close. What's the radical portion? The square root of -1, right? Which is I, right? So if I multiply this by I, then it'd be I squared, right? I gotta do top and bottom. What is I squared though, Cullen?
Drop it off.
Okay, that's it whenever it's an now look, that's an imaginary on the bottom, not a complex. I told you I'm gonna show complex. And I just took a second because this is what we did Friday. It's just that it's an I now. I'm still multiplying by the square root of -1. So, division by imaginary, multiply top and bottom by I. Okay? Y'all ready for the complex part? I've saved this for the last. I'm going to pause it and let you copy it. All right, here we go. So that was division by imaginary. This is division by complex. That was just, we're still in bullet point 4. We're just, did a little side note there. All right. Give me a random complex number.
My turn.
Okay, go Donovan.
2i
Complex.
plus 6.
The I comes second, so I'm going to do 2 plus 6i. Give me another one.
8 plus 3i.
All right. I got a radical in the bottom. I'm also adding or subtracting something down there. What did you do Friday? Oh, y'all are both absolutely right. We're going to multiply the top and the bottom by the conjugate. This time it's a complex conjugate. But conjugate's just a big fancy word that means change that sign in the middle and multiply. All right, so we're going to multiply top and bottom by the conjugate. So this is going to be a double FOIL problem. See why I said you get plenty of practice with the multiplying when we hit division? 8 minus 3i, top and bottom. Is anybody confused? No? Change the sign in the middle. When you multiply conjugates, the radicals go away. All right, let's FOIL up top. Y'all look like you're having so much fun. I can't wait to add to it for you.
So
No, that's it. But it's gonna be fun when we multiply this out, y'all. Look up top.
Don't add something.
2 times 8. 2 times negative 3i.
Negative
6i times 8.
negative 40.
6. Yes, 6i times negative 3i. Negative 18i squared. We're going to change them all. Yeah, we'll change them all. I'm watching some of you. Some of you, I think this is probably the first time in a math class where you're having to learn that you have to study a little bit and go back and practice. It's not coming to you as easy as just sitting in the class and watching the teacher and then that's it. That's all you have to do. You finally reached that point. You've never been to that point?
Never.
A lot of students get to Algebra 2 and they try to do what they've always done, which is just sit there and go, I'm just going to watch you work these problems and it'll click, and it usually does. Algebra 2 takes a little more than that.
I'm doing it right now.
All right, look at the bottom.
18.
What?
Oh, I'm talking about the negative.
Oh, I'm going to change all that in a minute. 8 times 8.
Whoa.
Wait till we get to tomorrow's my favorite. 8 times negative 3i. Plus 24i. Do you see the magic happening in the bottom? Minus 9i squared. All right, so several of you have said the I squared, the I squared, the I squared. Yes, we're going to change. I scream, you scream, we all scream for I squared. Okay. All right. Negative 18i squared is the same thing as positive 18. Negative 9i squared is the same thing as positive 9. Look up top, gather up your whole numbers. What do you have? 16 and 18?
4.
4.
4.
Negative 6i and 48i?
42.
Look at those i's that canceled out so nicely. Over 73. Oh my goodness.